blanks is talking about a type of reasoning. It is called inductive reasoning. Inductive reasoning. Inductive reasoning is a process of reaching a conclusion based on a pattern of examples, things that you see, okay? It's not based off of any facts or anything, it's based off some observations or patterns. So like, for example, you could say, you notice that I wear jeans and tennis shoes every Friday, so you're going to say, all right, well, this Friday, based off of what I've seen in the past, I know she's going to wear jeans and tennis shoes, right? Okay, something like that. Or you look at a set of numbers and you think, if I go from 1 to 4 to 7, what am I doing from one number to the next? That's what I'm seeing, what observations I'm making based off the patterns that I'm seeing, okay? When you assume that an observed pattern will continue, you're applying inductive reasoning, like I was just saying about the whole jeans and tennis shoes on Friday. You can use inductive reasoning to make an educated guess. That sounds like science, doesn't it? An educated guess. And that's based off of the known information and specific examples. Does anybody know or remember from science what an educated guess is called at a certain age?
Hypothesis.
That's correct. No. Hold on. Yes. Oh my gosh, my brain's going blank. Hold on. Oh, no, it's not either one. Just kidding. We are going to talk about hypothesis and conclusions starting tomorrow. This is a different word. Sorry, my bad. I wasn't prepared. It's a conjecture. Okay, a conjecture. Write that down. Conjecture. Next point. Write that down. Conjecture. Conjecture.
Was that hypothesis?
Well, that's what this word. A conjecture. So I don't know. It's kind of like a conclusion, but it's just based off of things that I see. We'll talk about hypothesis and conclusions tomorrow. Is everybody good so far? Mm-hmm. After I messed y'all up.
Hey, so Ms.
Saying wrong words, yes.
You can bring the F up.
Yeah.
Even though it's a test for me.
Yeah.
But it's gonna come up like slow, you think?
Mm-hmm.
For real? Mm-hmm. You don't do test retakes?
Nope. Okay, so this first example, it tells us.
Do it again, at least get a 70. Come on. You curved the test?
No.
Why you curve it?
Because I had somebody make 100. Why would I curve it? I had several people make A's.
7.
Yeah.
In this class?
Yeah.
100. I know one. 2 people got that?
I had like 4 A's in here.
Oh, yeah. You got a 50.
Oh, I got a 50 on that. The other one I got 100.
Are we ready to keep going? Okay. All right, so this example, it says to write a conjecture that describes the pattern in the sequence, okay? So we want to look at this pattern and see if we can figure out what the next time would be, okay? Then we're going to use our conjecture to find the next term in the sequence. So that means I'm going to look at the pattern. I'm going to see if I can recognize what's happening. How far am I going from one to the next? Then I'm going to make my conjecture. Okay, I'm adding this many minutes. So the next time would be, and then I can say what that next time would be. Okay, so look at your times on that example. The appointment times are at 8:30, 9:15, 10 o'clock, 10:45. So my conjecture, what I'm trying to, my educated guess, how much time is in between each appointment? 45 minutes, right? From 8:30 to 9:15, that's 45 minutes. From 9:15 to 10 o'clock is 45 minutes. And from 10 to 10:45 is another 45 minutes. So that pattern is consistent throughout that sequence. So therefore, if I wanted to know the next time, if I wanted to know the next time, I would want to know what is 45 minutes away from 10:45. 11:30. So guess what my conjecture is? My conjecture is that the next appointment is at 11:30. okay? Just based off of looking at the times that the first appointments were, how much time was in between each one, therefore I can say, what's next? Does everybody understand that? Okay. Now, I want you to look at that next pattern, okay? We're going to figure out what the pattern is. That's what we're looking at. What am I doing from one number to get to the next? And that has to be consistent throughout the entire sequence. And then I can tell what the next number is going to be. So if I go from 1/2 to 2, no, just kidding. 1/2 to 1 to 2 to 4. Now, it might not be easy to tell with that fraction, but how do I go from 1 to 2? There's a couple of different things I can do. I can either add, to go from 1 to 2, how much do I add? 1, okay? Or what else could I do? I could multiply by 2, okay? So let's take a look. I'm going to show you because I can write it up here. So I'm going to leave the fraction alone because we don't like fractions and those are hard to deal with. So we'll just focus on the other numbers. We said to go from 1 to 2, we could either add 1 or we could multiply by 2, correct? Well, my pattern needs to be consistent throughout. So if I go from 2 to 4, does adding 1 work? No, it doesn't. Does multiplying by 2 work? Yes, okay. So it seems like that's the pattern. So let me ask you this. If I multiply 1/2 by 2, does that give me 1? What's half of 2? 1, right? Okay. So my pattern is consistent throughout. Each time I'm multiplying by 2. So what would my next number be? 8. Does everybody kind of get the idea of what we're looking at here? We're just looking at patterns. What's happening from one to the next to the next. Okay. The next one. This one is going to be, it's a little bit more work, but it's not difficult. We just have to think about what it says. We're going to make a conjecture about the sum of the squares of 2 consecutive natural numbers. Well, first of all, let me clarify what those are. Natural numbers start at 1 and they go up. So 1, 2, 3, 4, right? Consecutive means numbers in a row, like 1 and 2, or 2 and 3, or 3 and 4. Okay? What does it mean to square something? Multiply it by itself. Okay, so I'm going to start with the first 2 consecutive numbers, okay? It says we want to look at what happens when we add the sum of the squares, okay? So if I do 1 squared plus 2 squared, what does that give me? What's 1 squared?
1.
What's 2 squared?
4.
What's 1 plus 4? 5, okay. So that's the answer to that. Let's try another pair. If I do 2 squared and 3 squared, 2 squared is 4, 3 squared is 9, and what's 9 plus 4? 13. Okay, I'm going to do another set. I'm going to do at least 4 sets. I'm going to do 3 and 4. 3 squared is 9, 4 squared is 16. You're about this close to make me take that from you. All right, let me do one more. If I do 4 and 5, 4 squared is 16, 5 squared is 25. What does that give me? 1, 2, 41. Okay, so look at the answers that I got when I added consecutive natural numbers, adding the squares of those. What kind of numbers are 5, 3, 25, and 41? They're all odd numbers, right? So would it be safe, now that I've done several examples, for me to say that if I add the squares of consecutive natural numbers that my answer is going to be odd? Did we find one that was even? No. So guess what? Our conjecture is the sum is odd, or you can just write it is odd. Okay, I did several different options. I did 1 plus 2, or 1 squared plus 2 squared, that gave me 5. I did 2 squared plus 3 squared, gave me 13. I did 3 squared plus 4 squared, gave me 25. 4 squared plus 5 squared, gave me 41. Okay, 4 of them is enough for me to make a conjecture based off of what I see. Are we kind of okay with this? Patterns is what we're looking at. No. Take that off your ear. I need you to focus on me, not focusing on your music back there. Okay? Let's look at the next one. Is it possible for more than one conjecture to correctly describe a pattern? Okay? So let's look at that sequence that they give us. What are those numbers that they give us right there? Look on your paper. What does it say? Okay. 2, 4, 6, 8, 16, 32, dot, 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 right? Okay. So if I'm looking at this, I'm sorry, I can't read this so small. We're in a square window. We got to figure out a pattern here. Well, at first it looks like I was just adding 2, right? Yeah. And then it looks like I went to changing it to multiplying by 2. I really don't think that 6 is supposed to be there. We're going to erase that. Erase that 6 out of your paper. That doesn't need to be there. Sorry.
We're multiplying by 2.
Right. So we're multiplying by 2, right? Yeah, that's what it needs to be. It needs to be times 2. That's my typo. I didn't need to add that 6 in there. Sorry about that, y'all. So we're going to multiplying by 2, right? So my one conjecture is my next number is going to be, what's 34? 32 times 2 is 64? Okay, let me ask you a question though. What if I said my pattern was 2 to some power? Let me ask you this. 2 is 2 to what power? 4 is 2 to what power? 8 is 2 to what power? 16 is 2 to what power? And 32 is 2 to the... Okay. So I could say 2 different things. I could say that we just multiply by 2, or I could say that we're raising 2 to a different power. So the answer is yes. Sometimes you will get a different conjecture than you will because there are 2 different ways to describe some of them. Okay, so if you don't get something exactly like your neighbor does, that doesn't mean it's wrong. There are times when you can have 2 different patterns describing the same, 2 different methods describing the same pattern. Okay, so the answer to that is yes, it is possible. Okay, so just remember, there's not just one specific way to describe a lot of these patterns. Are we okay with that? Kind of. I know all those words make a lot of... All right, make a conjecture about the sum of 2 odd numbers. Make a conjecture about the sum of 2 odd numbers. What I want everybody to do is pick 2 odd numbers, jot it down on the side of your paper somewhere, and add them together. You don't have to pick the same numbers because I'm about to start asking people what numbers they chose. So pick 2 odd numbers, like 1, 3, 5, 7, 9. Pick 2 of those, add them together, and jot that down on your paper somewhere. Pick 2 odd numbers, add them together, and jot that down on your paper. What 2 numbers did you pick?
13 and 15.
13 and 15. And when we add those together, we get 28, right? That makes sense? So, and what 2 numbers did you pick? 3 and 9. Okay. When we add those together, what do we get? 12. Adam, give me 2 different numbers you picked.
9 and 5.
Okay. And we add those together, that gives me 14. Ronald, what 2 numbers did you pick? 5 and 13. And we get 18. Okay. So 4 different sets of 2 completely different odd numbers. But what kind of numbers do I get every time when I add them together? Even. So guess what my conjecture is? It's going to be even. That's what I write. It's even. All right, look at that chart. What I want you to do, it says the gas table shows the average price of gasoline in the United States for the years 2010 through 2018. Make a conjecture about the price of gas in 2019. What I mean by that, is it going to be higher or is it going to be lower based off of the patterns that you see? So look in your chart, start with 2010, what was the gas price, then compare that to 2011 and keep going down the chart. See if you notice what happens. Are they getting higher or are they getting lower? What I want you to do is I just want you to write it's getting higher or lower under that example. We're not looking for a specific value. We just want to know, is it going to be higher or is it going to be lower? Did you notice it changes a little bit? So from 2010 it goes to 2011 it goes up, yes? And then it goes up again from 11 to 12. But then it goes down from 12 to 13 and from 13 to 14 and from 14 to 15 and from 15 to 16. But then what does it start doing? Going up. Now it went down for several years in a row and then it started going up. So what do you expect is going to happen? Higher or lower? It's going to get higher, yeah. Okay, just based off of what's happening now at the end of that list, it started to go higher and higher. So therefore we can only assume that it's going to get higher again. Okay, so a conjecture is just what you believe the next thing is in the pattern, what the next number is, what the next shape is, what happens when you do the same thing over and over again, like adding odd numbers. Okay. Now, to show that a conjecture is true for all cases, you must prove it. Like we did proof right here, okay? We did 4 cases. Now, that's not all of them, but that's a good amount with different numbers, so we were able to safely assume that we think it's going to be even. But it only takes one example that contradicts that conjecture, one that proves it wrong. Okay, it only takes one example to prove that wrong. Okay, that makes sense? I don't need 2, I don't need 3, I just need 1. Hold on. To show that a conjecture is not always true, we're going to give what we call a counter example. Counter example. That's going to prove that the conjecture is false. You can show me a number, you can do a drawing, or you can give me some words that prove it wrong. Okay, it can just be a number, it can also be a picture, and then it could be like a little phrase or something that could prove it wrong. All right, so let's look at this first one. Trying to make it bigger, sorry. It says, find a counterexample to show that each conjecture is false. If n is a real number, then if you put the opposite of n, it's going to be a negative number. Okay, first of all, what is a real number? Anybody know? What's this thing called? A number line. Okay. What kind of numbers are this way? This is the real number line. Okay. So what I'm saying is if I pick any of these real numbers, that my answer is going to be a negative answer. Okay, if I use the opposite of it. That's what this means right here. Hold on. This looks like negative n. That's the opposite of n. So if I choose 2, is the opposite of that negative 2? Yes. Okay, so that's not going to disprove that statement. But what if I choose negative 2? Is the opposite of negative 2 a negative number? No, it's a positive number, right? So guess what I could use? What did I just say? So all I would have to do is write negative 2. I could write any negative number as the example, and that would disprove that statement. That's all I need. All I need is 1. You don't need multiple, you just need 1. What else would work? What else would never be negative on this number line? 0. 0 would also be a good example because 0 can never be negative. So if you do the opposite of 0, it's not going to be a negative because there is no such thing. Okay. Now the next one says, if angle ABC is congruent to angle DBE, then angle ABC and angle DBE are vertical angles. Can you draw a picture to disprove that? Okay. What if I just did this? I had to look at my numbers. What if I drew angle ABC and then I drew, oh, hold on, let's do it this way. Angle ABC is here. Angle DBE is here. Are those vertical angles? So guess what? I could draw that picture. That's my counterexample. I could also just draw two separate angles. A, B, C, D, B, E. Those are also not vertical angles, are they? Okay. So that one, all it took was for me to draw a picture to say that that is not true. Just because they have the same vertex does not mean they're vertical angles. Okay, so either one of those pictures or any kind of picture that's not showing vertical angles would work. And I want everybody on your paper to try to draw an example of this last one. It says if a line intersects a segment, so first of all, draw a segment at the bottom of your paper. Call it AB. Okay, label that segment AB. What this is saying is if I have a line that intersects that segment, it has to be perpendicular. So draw me a line going through the middle of that segment that's not perpendicular.
What direction is
Perpendicular means 90 degrees. Okay, so draw a segment AB, and then what I want you to do is draw a line right through that segment in the middle that is not perpendicular. That's how we have to prove that. Just because it goes through the middle of my segment does not mean that it is going to be perpendicular. There's my middle, I'll call it C, okay? Draw a line through that that is not perpendicular to segment AB, and that will be your counterexample. A lot of times that's all it takes is a picture. Draw that line segment and then draw a line that goes through C but not perpendicular. Meaning don't draw it straight up and down. You can draw it in any direction. That's what a counterexample is. It's just something that disproves that statement. So I could draw a line. Let's pretend like it went through there. Let's try that one more time. Like that. That's not perpendicular, is it? Could I also draw one this way? Still not perpendicular, okay? But you only need one. So a lot of these are just pictures that you can draw.